So, what do we have here? So I decided to use normal distributions for all variables for the sake of simplicity. It could also be log normal in order to avoid negative values when we have a mean which is close to 0, for instance, for cohesion or something like that. And the coefficient of variation which has been assumed is 25% on the stiffness, 10% on friction angles, 20% on cohesions, and 10% on the water table. I haven't added model uncertainty here, but this could also be done, of course. How do we back calculate distribution parameters from usually characteristic values, at least with the actual Eurocodes or norms? So from the characteristic value, let's take the friction angle of soil 2, for instance, which I got from the Geotechnical report that I got from the Geotechnical company. It actually already includes implicit spatial averaging, and this is obviously geotechnician dependent, so if you take two different companies, maybe they will come up with two different friction angles, but that's the whole point of using a probabilistic analysis, right? Then you take, or I take, this coefficient of variation, which is denoted V actually in the guidelines. I use COV from all presentations, but this is V that Johan was just speaking before from the literature. And I get the mean value. Then I can use, in my probabilistic computation, I can use the mean value for phi 2 with the standard deviation for phi 2. I was speaking during the coffee with some other colleagues, and of course, the more site investigations you get, the more samples you can test, the more you can reduce this coefficient of variation, and therefore, the more you can reduce the standard deviation, and then, of course, you can optimize your design. But it's always difficult, at least when I talk to contractors or to the guys who pay, it's always difficult to tell them that you want more tests, and somehow we have to spread the word that more testing will therefore also optimize our designs, I think. So you see here these three different values for E, phi, and C for soil 1, E, phi, and C for soil 2, E, phi, 3 for soil 3. You can see the mean values here, you can see the standard deviations, you can also see here the mean value and the standard deviation for the water here, which is actually, which comes actually from what I got from the Geotechnical report.